Welcome back, you guys. It's Mr. Romero. Today's lesson will talk about elements. So, an element is a substance that cannot be broken down into smaller substances by any chemical means. Meaning, like this example right here, this is an element of magnesium. So, the element of magnesium has magnesium atoms. It's not magnesium mixed with other things like chlorine, sulfur, oxygen. It's not magnesium and aluminum. It's not magnesium and carbon. It's just pure magnesium. So it is a substance or an atom that can't be broken down into smaller substances by any chemical means. So elements is another fancy word of saying, hey, what are we just simply talking about? Are we talking about magnesium atoms? Are we talking about sulfur atoms? So, elements are things that cannot be broken down into smaller substances. Here we have a couple elements. We have lithium element, the element of lithium. The lithium element has lithium atoms. Here we have nitrogen. Nitrogen element has nitrogen atoms. Sulfur element. The element of sulfur has sulfur atoms, and so on and so forth. So, in summary, elements are things that can't be broken down into smaller parts by any chemical means. So you can try to separate it the best that you can by chemicals, but you can't. So an iron element cannot be broken down into something else like manganese or chromium. So if we are talking about iron element, it is just pure iron that is comprised of just iron atoms. Another thing about elements is that an element is composed of atoms, like I previously mentioned, and they have the same number of protons in their nucleus. So, for example, here we have a box on the periodic table, and this represents magnesium. Magnesium element has magnesium atoms. Magnesium is represented by Mg, and it has an atomic number of 12 with an atomic mass of 24.305. So magnesium element has magnesium atoms. Like we previously discussed in our previous lesson, this is an example of an atom. This one in particular is an atom that has 1, 2, 3, 4 protons, 1, 2, 3, 4 neutrons, and 1, 2, 3, 4 electrons. There are ways for us to figure out what type of atom we are trying to figure out here, and that is by counting the number of protons. And we'll discuss that in a few slides from now. So here we have nitrogen. What is circled here in green is nitrogen. This is a nitrogen element, and the nitrogen element is very pure. It only has nitrogen atoms. Here we have a magnesium element, and it only has magnesium atoms. So, a little bit more about elements. This is a magnesium element. There are a few things on this element box, and that is this number at the very, very top. Here we have something called an atomic number. Every element has a unique atomic number. What is the atomic number of magnesium? It is 12. It indicates the total number of protons in the nucleus of an atom. So in this example right here, we have magnesium. The atomic number tells us that there are 12 protons in the nucleus of this atom. So this number at the top on every little element on the periodic table lets us know how many protons are in the nucleus. For example, if we are talking about boron, the number at the very top here is 5. There are 5 protons in the nucleus of boron. If we are talking about silver, Ag, this number at the very, very top tells us that there are 47 protons in the nucleus of the atom of silver. Here's another example. The atomic number, which is the number at the very top, tells us how many protons are, if we were to draw it out, if we were to draw out fluorine, It tells us how many protons are inside that atom, and that can be translated to what is off to the right. Here we have a fluorine atom. We have the electrons on the outside, which there are 9, and we have the nucleus that has protons and neutrons. And if we were to count the protons and the neutrons, there should be in fluorine 9 protons and 10 neutrons. So the link here, the little cheat code, is that if you look at the number at the top, the atomic number, that represents how many protons are in the nucleus of that atom. Here's another example. I want you to answer this. What is the atomic number of this element? The atomic number is 22. There are 22 protons in the nucleus of a titanium atom. Here's another example. What is the atomic number of this element? You're correct. It is not the number at the bottom, it is the number at the top. So fluorine has an atomic number of 9. That means if we were to draw out fluorine atoms, there should be in every fluorine atom 9 protons inside the nucleus of a fluorine atom. Good job. So a little bit more about atomic number. Normal atoms are electrically neutral, meaning that on the periodic table, whatever you see right here, every box on the periodic table, for the most part, is electrically neutral. That means they are not unstable, they are completely neutral. So they have the same number of protons as they do electrons. That's another trend that seems to be on the periodic table. So it is also the same number of electrons. This is what I mean. Here we have an atomic number of 9 for fluorine. If you notice, look at these two numbers. What do you notice is the same or different about them? Good. If we have 9 protons, because this atom is neutral, there should also be 9 electrons. Because protons are positive, P for positive, and electrons are negative, the positive and the negatives cancel out. This is why fluorine is neutral here. There's 9 protons, which are positive, so 9 positives and 9 negatives eventually cancel out. For every positive and every negative, it becomes completely neutral. So at the end of the day, this guy is neutral. And every element on the periodic table is neutral because the number of protons matches the number of electrons. A couple more characteristics about elements. So we talked about the atomic number. Now let's move on to the atomic symbol. So the symbol is basically the 1 letter or the 2 letters, or in some cases the 3 letters, depending on what periodic table you're looking at, that represent that specific element. Every element is abbreviated, so that means it's shortened down using a unique symbol of 1 or 2 letters. So, for example, magnesium is abbreviated by 2 letters. Here, sodium, which reacts very violently with water, is abbreviated by 2 letters, Na. If we look at aluminum, it is abbreviated by 2 letters, Al. What is the abbreviation of cobalt? Co. What is the abbreviation of sulfur? S. Good job. And lastly, what is the abbreviation of vanadium? Good, just V. So it can either have 2 letters or 1 letter. However, the first letter is always capitalized, and if there is a second letter, it is always lowercase. Here there are 2 letters. The first one is capitalized, and the second one is lowercase. Another example, nitrogen has an abbreviation of N, only 1 letter, and the 1 letter is capitalized. Fe, iron, has an abbreviation of Fe. The first letter is capitalized, the second letter is lowercase. A little bit more about atomic symbols. So some are based on other languages. For example, the symbol Fe is iron from the Latin ferrium. So different languages back in the day helped contribute to the establishment of the periodic table and its naming sequence. Here, Fe for iron is from the language origin of Latin. A little bit more, now shifting over to the element's name. First, we talked about atomic number, then atomic symbol. Now let's talk about the element's name. So every element has a unique name. Many elements' names are very old and are based on other languages, something that we previously discussed in the previous slide. For example, manganese, that is that has an ancient origin, which I don't know what the ancient origin of this is, but it probably originates from either Latin or Greek. A little bit more about element's name. Here's an example. Chlorine is named after chloros, the Greek word for yellowish green. This is also chloros, is very similar to the Spanish word of cloro. Cloro in Spanish is basically chlorine. And it seems like Spanish also has some type of similarities with Greek, the Greek origin of chlorine, which is chloros. So far we've known that some elements can either be Latin, from Latin origins, or even Greek origins. A little bit more about elements' name. Newly discovered elements are named by the discoverer, but must be approved by an international committee. So let's say someday you become a renowned scientist, and you were to discover a new element. You could potentially name it after yourself if an international committee approves it and says, hey, this guy discovered it. You know what? Let's give him some credit. Let's allow him to name this element after him. Here are some examples of the most recently discovered elements and their origins. Here, our first one is nihonium. Nihonium has an atomic number of 113, and it's over here, NH, and it was discovered by Japan. Another one is tennessine. It has an atomic number of 117, which is represented by TS, and it was discovered by the United States, specifically in the state of Tennessee. Now, oganesson, which is represented by OG, was discovered by a Russian nuclear physicist, Yuri Oganesson. So if you see here, they named this element after Yuri, which is the guy that discovered this element. They named it his last name. His last name was Oganesian, and then they named this element Oganesson. So very similar to his actual last name. This is one of the heaviest elements that are on the periodic table thus far. Now, shifting over to our last characteristic of elements. Elements have something called an atomic mass. The atomic mass of this specific element, magnesium, is 24.305. Atomic masses is the mass of the protons plus the neutrons in an atom. So if you combine out of the three things that make up an atom, the protons, neutrons, and electrons, if you combine just the protons and the neutrons, you should get the atomic mass. Every proton and neutron has a mass of 1 AMU. So protons weigh 1 AMU, neutrons weigh 1 AMU. Here's that little cheat sheet that I showed you in the previous lesson. Protons have a charge of a +1 charge, but these guys do weigh 1 AMU. Neutrons have a 0 or neutral charge, and they weigh 1 AMU. The reason why we don't calculate for atomic mass, like the overall mass of the atom, using electrons, it's not so much because they have a -1 charge. The reason why we don't count the number of electrons and how much they weigh, because it's irrelevant. They are so tiny and weigh very little that it's very close to 0 AMUs. They don't contribute any mass at all to the overall mass of the atom. Here's an example. A carbon atom has a nucleus. In the nucleus, we have protons and neutrons. And on the outside, we have electrons. In the nucleus, we have neutrons and protons, which both weigh 1 AMU. So if I combine the total AMUs of the protons plus the total AMUs of the neutrons in the nucleus, I should get my atomic mass. Here, I have 6 neutrons. 1, 2, 3, 4, 5, 6. 6 red. And then I also have 6 protons. 1, 2, 3, 4, 5, 6. To give me an overall number of 12. That is the atomic mass of carbon. I'm only counting what is inside the nucleus, not what is on the outside of the electrons. These guys weigh 0 AMU, which is why I'm not really counting for them as the overall atomic mass. For example, here, aluminum has an atomic mass of 26.982. Boron has an atomic mass of 10.80. Oxygen has an atomic mass of 15.999. That can easily be rounded up to 16. Here's another example. In this example, we have lithium. The atomic number for lithium is 3. The atomic symbol is Li, and the atomic mass is 6.941. The atomic mass of lithium is 6.9941 AMU, or if we were to round this up to the nearest whole number, which is the 6, if I look at the whole number, which is the 6, and the one next to it, if it's 5 or more, you add one more, and that gives you the overall whole number. If I look at 9, it's bigger than 5, so I'm going to add 1 to the 6. That gives me an overall atomic mass of 7 if I round this number up. So, like we discussed earlier, electrons do not count towards the mass because they are tiny. One more time. Electrons do not count towards the mass because they are tiny. Good job. All right. So, a few more things about atomic mass. The mass can be shown with a decimal because it is an average mass of the isotopes that make up that element. Isotopes is just a fancy name for the different versions of magnesium. Let's say I were to carve a hole in the ground and I were to discover magnesium. Well, I won't just discover magnesium that weigh 24.305. I might find one that weighs 25.16 or 23.5, or I might find one that weighs 24.603. I might find another one that weighs 24.1. So what scientists did is they got all of the magnesiums that could exist out in nature and they just took the average. And that is the number that you see here. That is the average or the total average isotopes that exist for that specific element. But long story short, you can either write it in decimal form or in whole number form. I want you to practice here. Instead of circling, I want you to just think to yourself, what are the atomic masses that I see here? Okay, what is the atomic mass for gold? If I were to round the atomic mass for gold, what would it be? If I were to round the mass of titanium, what would it be? And finally, if I were to not round and just keep the mass of lithium, what would be the atomic mass of lithium? All right. So, in summary, here's the shortcut. Atomic number is equal to the number of protons. And atomic mass is the number of protons plus the number of neutrons. This is a cheat code. This is a way for you to quickly remember what atomic number is and what atomic mass is. Now I want you to practice. What is the atomic number of this element? Hint, count the number of protons only, then look at the periodic table. Remember this cheat code right here. Atomic number can easily be found by doing this, counting the number of protons. Good job. The atomic number of this element is 6, and 6 on the periodic table belongs to carbon. Okay, and carbon right here has an overall mass of 12, not 13. Sorry, this is a typo. It has an overall mass of 12, or 12.011. Now, what is the atomic mass of this element? I kind of gave you the answer already. Hint, count the number of protons and neutrons and then put the value in AMUs. What is the atomic mass of this atom? Good. So, again, sorry, typo. There is, in this particular atom, for us to find out the mass, we don't count the electrons. They're really tiny and they don't weigh anything. So let's actually count this. How many neutrons do I see? 1, 2, 3, 4, 5, 6, 7. Oh, there's 7 neutrons, and they are in yellow. Now let's count the number of protons. 1, 2, 3, 4, 5, 6. 6 protons, which are in red, give me an overall total mass of 13 AMU. 13 AMU. Electrons do not count to the overall mass. Okay, now what is the atomic number of this atom? Good. It is 6 because there is 6 protons. And that belongs to carbon. What is the atomic mass of this atom? Hint, count the number of protons and neutrons, then put the value in AMUs. Let's see. How many protons do I have? Protons are in blue, so let's count them. 1, 2, 3, 4, 5, 6. 6 protons. Plus, let's see how many neutrons. 1 neutron, 2 neutrons, 3 neutrons, 4 neutrons, 5 neutrons, 6 neutrons. 6 neutrons, they're in red. So 6 protons plus 6 neutrons gives me an overall AMU of 12. So overall, if you were to look at the periodic table, what element is this based off of the periodic table? Good. It is carbon because it has an atomic number of 6. Now the mass can be different. We've seen other examples that have either an atomic mass of 12 AMU for carbon or an atomic mass of 13 AMU for carbon. Sometimes atoms are different. They're slightly different, but the number of protons is the one that matters. Okay, couple final more practice questions. What is the atomic number of this atom? What element is it? And you have now accomplished all you need to know on 8th grade physical science about atoms and elements. Good job.